Let's take a look at a variety of industrial robots. Here we see two small 6-axis robots. The larger one has a payload of 3 kilograms, and the smaller one has a payload of 500 grams. Next is a range of 4-axis robots designed to pick up a part, rotate it, and place it. This class of robot can often move very quickly with a pick-and-place cycle of 300 to 500 milliseconds, with payloads of a few kilograms. Tool speeds can reach 10 meters per second, making these small robots very dangerous. Another example of an industrial robot is a large 6-axis robot spot welding line. These robots typically have a 100-kilogram payload, so obviously this is a very powerful and dangerous robot. A 6-axis collaborative robot can also work together with a person who is loading a part onto the robot end effector prior to the robot installing the part in a difficult-to-access location within the automobile. And here is a line of 2-armed robots working in a factory in Japan that makes change machines. Recently, there has been some interest in humanoid robots that can work with 2 arms to reduce the need for fixtures to hold parts. Now let's take a look at some examples of service robots. Here we have the Da Vinci surgical robot from Intuitive Surgical. This robot is a master-slave robot where the surgeon is sitting at the table and has a 3D virtual reality headset that displays a stereo image from 2 cameras that are mounted on the ends of laparoscopic tubes inserted inside the patient's body. The surgeon manipulates 2 forceps-style grippers which control the motion of miniature tools on the ends of the 2 more laparoscopic tubes inside the body. Hundreds of these systems are now in use worldwide, performing a variety of operations. Here we see something completely different, a large industrial robot that has been converted to an amusement park ride, waving around in the air some either very brave or very foolish people. Next, we see a hospital service robot that has enough strength to carry a patient around. This is only a concept at this time. The last service robot we will present is a fruit-picking robot working in an orchard. There is a fair bit of interest in developing robots that can work outdoors in dirt and mud and perform various tedious agricultural tasks such as picking, weeding, transplanting, and spraying. Robots are now rolling around and in a few cases walking around. Precise Automation sells a collaborative robot to Adept Technology, who mounts it on their autonomous mobile base, which carries around a box containing semiconductor wafers from tool to tool in semiconductor factories. This is an example of a robot that can service multiple tools 24 hours a day. Here you see the Kiva autonomous vehicle delivering picking racks to a human picker in an Amazon warehouse. An elaborate planning system tells a bunch of mobile robots which racks to bring to a human picker, so an order can be picked at one location without the need for the person to run all over the warehouse. This dramatically improves the efficiency of the pickers. Serving robots are now emerging at some fast food restaurants in Japan. Customers first place their orders on tablets at their table, and then the serving robot rolls up with a tray which the customer removes and returns when done. This mobile base has omnidirectional wheels. If these wheels with rollers all turn in the same direction, the robot moves forward. If they turn in opposite directions, the mobile base moves sideways and can therefore move in any vector without steering. The robot is able to load items onto the platform or place them into a bin. Robots are increasingly being used to work in very dangerous environments that humans cannot enter. Most people are familiar with the Mars rover, which wanders around and takes soil samples. Here are some less well-known types of robots that enter hazardous environments. This is an underwater seafloor mining robot developed to mine manganese nodules and other minerals from the seafloor. Note the size of the person standing next to this huge machine. Here is a firefighting robot which can move into much hotter and more dangerous situations than a human firefighter. This is an autonomous underwater survey robot which can follow a planned route and collect data for some weeks at a time without control from the surface. And here is a very scary robot, a military robot that is remotely controlled by a person. However, some planners are suggesting military robots might make decisions by themselves, which raises a lot of very serious ethical questions. Finally, when we think about robots interacting with humans, one of the most compelling forms of robot is the android, or humanoid type robot. Mentally, we equate a human shape with human abilities, including perception, reasoning, communication, and manipulation. Android-type robots have been a topic of fascination in Japan for many years, although less so in the US and Europe. Honda has had a program which has received a fair bit of publicity with an android they call Asimo. You can see the evolution of this design moving from a pair of legs used to study walking and balance to a complete robot with some simple multi-finger hands. This robot really can't do anything useful yet other than walk around. After about 20 minutes, its battery runs out and it falls over. In summary, there are many classes of robots emerging, and most of the newer types of robots will be interacting with people. So understanding collaborative robots is very important.